Okay, so when I say computer science, what pops into your head? For most of us, it's probably a coder, right? Headphones on, maybe in a dark room, with all that green text scrolling down a black screen. But what if I told you that's like judging the entire history of storytelling by looking at a single tweet? Today, we're going to peel back the layers on what this field is really all about.
So let's just ask it, what is computer science? Is it just about coding or building the next big app? I mean, that stereotype, it barely even scratches the surface. It's like trying to understand an entire library by just looking at the cover of one book.
To really get to the heart of it, we have to bust a few myths. We're going to look at what people think it is versus the surprising reality. You're going to see that computer science is far from a new field. It's definitely not just the work of lone geniuses, and it's anything but a neutral tool. The truth is actually a much richer and way more human story.
Let's start with that first myth, that computer science is all about shiny new machines. The tech world is obsessed with what's next, right? The future. But to really get a handle on CS, we need to look back, way, way back, into its surprisingly deep history.
It's kind of funny, we think of computing as this super recent revolution. But the core principles, the actual math and logic that make your phone and your laptop work, those were being figured out a whole century ago. Everything we build today is standing on that very old foundation.
And this brings us to the real heart of computer science. It's not the machine itself, but the idea that makes the machine run. And that idea is the algorithm, a concept that's literally thousands of years old.
I mean, just look at this timeline. The human quest to automate calculation started long before silicon chips. We've got the abacus from thousands of years ago, built to handle trade and accounting. Then, in the 1600s, you get Napier's logarithms, invented to make the brutal calculations for astronomy and navigation a little easier. Fast forward to the 1820s, and Charles Babbage is designing these amazing mechanical engines to get rid of human error in math tables. And by 1890, Hollerett's machine was built to solve a national crisis, a U.S. census that was taking almost a decade to count by hand. This is all before digital computers, but it's all part of the same human drive to create a process, a set of rules, to solve a problem.
So, this is the key. An algorithm, it's just a sequence of precise instructions. That's it. You take some inputs, you follow a limited number of steps, and you get an output. This simple concept is what underpins every single thing a computer does. And honestly, the best way to think about it is this. It's like a recipe. Your inputs, those are the ingredients. You follow the precise instructions. Combine this, heat that, stir for a bit, and you produce an output, a delicious meal. A recipe is an algorithm. This simple idea is the building block for everything, from streaming a movie on your couch to guiding a spacecraft to Mars.
So, if the algorithm is the recipe, what's doing the cooking? Well, this brings us to a really fundamental split between hardware and software, the machine itself versus the idea that actually gives it a purpose.
Okay, let's break this down real quick. Hardware is the physical stuff you can touch, the silicon processors, the lithium in the batteries. You could call it the body of the computer. Software, on the other hand, is totally abstract. It's the set of instructions, those algorithms we talked about, that tell the hardware what to do. It's the brain, or maybe the plan. And you absolutely can't have one without the other.
And here is a fact that might just bend your brain a little. The ENIAC computer from 1945, this thing was the size of a room, a total behemoth of vacuum tubes. It could fundamentally solve the same types of problems as a modern supercomputer. Yeah, it would just be, trillions of times slower. That's because they're both what we call Turing-complete, which is a fancy way of saying they have this universal ability to run any algorithm. Think of it like this. A little kid with an abacus and a math professor with a fancy calculator can both solve the same addition problem. The difference isn't what they can compute, it's all about how fast and how efficiently they can do it.
Okay, and this brings us to what might be the most important part of the story, the people. The myth of the lone genius coder, working away in isolation. It's just that, a myth. The real history of computer science has been shaped by all sorts of different people, and a lot of their stories have been kind of erased from that main Silicon Valley narrative we all know.
Hey, remember that giant ENIAC computer we just talked about? Well, it was largely programmed by women. Their job was to take these incredibly complex math problems, like calculating missile trajectories for the military, and translate them into instructions the machine could actually understand. They weren't just button pushers. They were the original software engineers, figuring out the very practice of programming as they went.
And the list of these overlooked pioneers is so long and so powerful. You've got Katherine Johnson, a black human computer at NASA. Her calculations were so trusted that astronauts asked her to personally double-check the work of the first digital computers before they'd fly. You've got Roy L. Clay Sr., who is key to starting HP's first computer lab and helped steer investment to future giants like Intel. And Mark Dean, an engineer at IBM who holds 3 of the 9 patents for the original PC. I mean, these aren't small contributions, they're foundational.
But being a pioneer in a field that doesn't always see or serve your community, well, that comes with a heavy burden. This quote from Kamal Al-Mansour, who worked at NASA's Jet Propulsion Lab, is just wow. It's so telling. He felt this deep conflict, building these amazing, powerful technologies, but feeling like none of it was actually helping his own community. It just really drives home the human and social side of all this work.
And that leads us right into our final myth. The idea that technology is neutral. You hear it all the time, right? A tool is just a tool. Well, no. The way we design, build, and decide who gets access to technology is packed with choices and values that have huge, real-world consequences. One of the most obvious impacts is something called the digital divide. This is basically the gap in access to technology. I mean, think about it. If your education, your job prospects, even your access to healthcare are all tied to having high-speed internet and a decent computer, then not having access isn't just an inconvenience. It actively makes social inequality even worse. A classic case study in this is the One Laptop Per Child project. The vision was beautiful, right? Bring cheap, tough little laptops to kids in the global south and completely transform their education. But the reality was a total mess. The project crashed into problems with electricity, the hardware kept breaking, and there was this fundamental misunderstanding of the social and educational worlds they were trying to enter. It's a perfect example of how just dropping technology into a community without really understanding it is never the answer.
So what's a better way forward? Well, this idea of design justice, which Sasha Costanza-Chock talks about so powerfully, offers a new model. It's about a huge shift from designing for communities to designing with them. It's about centering the knowledge and the real needs of marginalized people in the creation process from the very beginning.
So we've gone on quite a journey. We started with the myth of the lone coder and ended up with the reality of computer science as this ancient human quest for problem solving. It's a field shaped by all kinds of people and loaded with social impact. And all of this leaves us with a really critical question to think about. If technology is never neutral, then who should get to decide what we build with it, and whose lives does it ultimately serve?